Hey, good morning, everyone. All right, so before we get started on the midterm review, do you have any question? Okay, so I guess, again, feel free to let me know my pace, right? If I go too fast, let me know. I can slow down a little bit. Okay, so let's go to the midterm review. Okay, so just click on homework test, right? And then underneath it, you will see the midterm exam review sheet. And we can get started. Also, I'm removed some of the questions from the midterm exam review. And let's take a look at it. Okay. So some of them are multiple choice questions testing the concept. And some of them are the word problem. You have to work it out using a formula and then get those statistics. So first of all, first question, determine whether the underlying number is a statistics or a parameter. So sample of employees is selected, right? Definitely it says sample here. So this is sample statistics we're talking about. And it's found that 25% on the computer. So definitely this is statistics because it comes from the sample. And the value is a numerical measurement describe the characteristics of the sample. So should be answer choices, first answer choice, okay. And second one, a particular country has 40 total states. If the area of 40 states are added and then the sum is divided by 40, the result is 210,114 square kilometers. Determine whether this result is a statistics or parameter. So again, there are only 40 total states. So you are including all 40 states. That means it's a population. So we're talking about population. And then you add, based on this population, you calculate the average area for each state. So that we call this population parameter. So the result is a parameter because it describes some characteristics of a population. Okay. Any questions so far? Okay, so this is parameter. Yeah. Which of following consists of discrete data? Discrete data is the numerical data, finite, countable numerical data. So here, the only thing satisfy that will be the number of suitcases on the airplane, right? The rest of them is what we call the amount of rainfall is what we call a continuous random variable. It has an interval, and interval has infinite many values, data values available. Tree height is also a continuous random variable. And the hair color is what we call the categorical data. Categorical, or you can also call that qualitative data. Okay. But yeah, the discrete data would be the first option here. All right, which of following could be classified as categorical data, right? I already mentioned that it has to be a hair color. That's only categorical data. We also call this qualitative data. Okay. Any questions on this? Okay. Now let's, I remove question number 5. And question 6. All right, after constructing relative frequency distribution, summarizing IQ scores of college students, what should be the sum of the relative frequencies? So relative frequency basically is a percentage or decimal numbers. So this total of all the percentage will be 100%, right? If the percentage are used, the sum should be 100%. If proportion are used, the sum should be 1. Right? Total probability is always going to be 1. Yep, so that should be it. Question 7, I omitted. Question 8, okay. So basically, for this question, we have a frequency distribution table. Given a frequency distribution table, I want to find out the class width, class midpoint, and also the class boundaries. So I'm going to export it as an Excel file, and then we're going to walk through each one of these calculations step by step. Let me open it first. You can also open the Excel file, and we can just work on this Excel file. Okay. All right, so let me share the screen with you. There we go. Okay, this is Excel file. Now you can just enlarge it, right? Just make it slightly bigger. Okay. Enable editing here. So we need to calculate a couple of things. Start with the class width. That's most important thing. Okay. So I'm gonna format it a little bit. Okay. Center. Okay. So start with the midpoint. No, class width. So class width is the difference between the two consecutive lower class limit or upper class limit. So basically you're using, so the easiest thing to do is using 68 minus 64. Find the difference between two neighbors, right? These two neighbors, two consecutive lower class limit or upper class limit. So that turned out to be 4. Okay. So you find the class width, it turned out to be 4. Now we start with the class midpoint. So the first class midpoint, I'll do it here, midpoint. So midpoint basically average those two numbers. Average is 64 and then 67.9. So you're adding 64 plus 67.9 and divide by 2. Okay. All right, so that should be the midpoint for the first class. And for the second class, very similar. We perform the same procedure here. So you add in the 68.0 plus 71.9 divided by 2. Second class midpoint. And then if you notice that the difference before between the consecutive midpoint here. So basically the class width actually is a pattern we can utilize to generate the next one. So for next one, using the previous one, adding 4. So using this, adding 4. Okay, you get next one because class width is 4. And again, using this, adding 4, you get next one, right? And if you want to follow this formula, get the rest of them, you can do that. Okay, it will automatically generate the rest of the class midpoint. And you can double check the last one, right? Make sure it does follow the right formula. So just double check the last one. Okay, all right, 2. It turned out to be the same. Okay, that means you have the right calculation. So this is all the class midpoint. And then class boundaries. Okay, guess I will put here boundaries. Also follow the same patterns, right? So the difference will be 4. So if you calculate the first one, in the first class, okay, no, actually, let's get to the second one first. So it will be the middle of 67.9 and 68. So you just average 67.9 and 68 and divide by 2. That will get the second one. And applying the pattern, right? The first one should be this number minus 4. And if you look at this number, it should be right in front of the 64. If that's the case, that means you have the right class boundary. Okay, for the first one. And from there, we can just add this by 4, right?
What did you do on D3 again? Or was it
Okay. For the second one, for the second class boundaries, I just average those two numbers, 67.9 and 68. So the class boundaries separate the first class and the second class. Okay. Does that make sense?
Yes.
All right, great. And now after that, if you do not want to calculate that one by one, you can just use the pattern, right? Just pattern is adding 4 to the previous one, you will get the next one. All right, so once you do one of them, then you can just drag all the way to the bottom, right, to get the rest of them. And then one more, right? One more after the last one. So we should have the class boundary after the last class, which is 103.95. And you can double check this one if you want to double check that really quickly, make sure that Excel is doing the right thing. So just average 99.9 and then 100. So 99.9, adding 100 and divide by 2. And that should be the same number. And that means all these numbers should be good. Okay. So we get class width, midpoint, and then class boundaries. Okay. Any questions on this? All right. And you can just go back there and then input all these numbers into the review sheet. Okay. All right, let's move on to question 9. Okay, again, we have how many classes? 7 classes. Okay, I guess I can make it slightly smaller. So we have 7 classes with frequencies and daily low temperatures here less than 40. So meaning you accumulate in the first class, right? Less than 40 will be just the first class. So cumulative frequency will be just 2. And less than 45, that will be accumulating in the first 2 class. So you add in the frequency from first class and second class, 2 plus 3 give us 5. Okay, that's good. Less than 50, 50 is right here. So less than that, you accumulate in the first 3 class, 2 adding 3, adding 6, that's 11. Okay. And less than 55, accumulating the first 4 class. Okay. And adding 11 to 12, right? That should be 23. Or if you sum up the frequencies from first 4 classes, that also get 23. And less than 60, that will be accumulating the first 5 classes. So 23 adding 8, that will be 31. Okay. And some of you guys may have slightly different question, right? Because midterm exam review actually randomize the question first of all. Also, they may change the number slightly. So your question could be slightly different from mine, but the thinking process and then all these procedures will be identical. And less than 65, they're accumulating the first 6 classes. So adding 31 by 8, that should be 39. And then the very last one, you less than 70, right? So we'll be accumulating everything, all the classes, all 7 classes. So 39 adding 1 becomes 40. If you look at it, the total frequency should be 40.
Sorry, Professor.
Yeah.
I can only see the Excel right now. I'm not on the question.
Okay. I forget to share that, I guess. Okay, so this is the question. This is question 9, right? So question 8, we already complete all the process. And question 9 is about the construct cumulative frequency distribution for the given data. So first question, first part is less than 40. Less than 40, 40 is right here. Less than 40, that means cumulative frequency will be just 2. And second one is less than 45. 45 is right here. So you are accumulating the first two class in terms of frequency, adding 2 and 3, you get 5. And then the third one, less than 50, 50 is right here. So we are accumulating the first three class, the frequencies from first three class, 2 plus 3 plus 6 is 11. Okay, and less than 55. So we are accumulating the first four classes. Then we have 11 adding 12 becomes 23. Then less than 60, very similar, accumulating the first five classes in terms of frequency. We just add an additional 8 here. So 23 adding 8 becomes 31. Then less than 65, accumulating the first six classes. So 31 adding 8 becomes 39. And less than 70, meaning we accumulating the first all 7 classes in terms of frequencies. So that should be 40, right? Eventually. So any question on this? Okay, that should be fairly straightforward. Just cumulative frequencies we have to calculate. All right, so now next one, using the given qualitative data to construct the relative frequency distribution. So there are 2,528 people aboard the ship that sank, include 494 male survivors, 1,605 males who died, 316 female survivors, and 113 female who died. And basically, you just want to calculate the relative frequencies. So male survivors, there are 494 male survivors out of 2,528. So here you just have to do this, dividing 494 by 2528. Okay, and whatever that percentage is, how many decimal do they want? They want to run one decimal place. So let's see what that is. So 494 divided by 2528, and this turned out to be 19.5%. If you run it to one decimal place in terms of percentage, so it's approximately equal to 19.5%. So the answer will be that. Okay, so in terms of putting the answer, you only put 19.5%, right? You do not put a fraction in. I just show you the complete calculation. Okay, and the second one, male who died, we have 1,605 male who died, divided by total people on board. So 2528, and let's see what that is. So 1605 dividing by 2528. And this turned out to be 63.5%. If you run it to one decimal place, 63.5%. And female survivors will be 316 over 2528. Let's see what that is. 316 by 2528. This is 12.5%. And then the very last category is the female who died. So it'll be 113 divided by 2528. And let's see what that is. 113 by 2528. And this turned out to be 4.5%. Run it to one decimal place. 4.5%. Okay. Any question on this? Just basically split all these different categories in using percentage to represent, we call these relative frequencies to represent each category here. Okay, question 10 and question 11, I omitted question 12, okay. Now here's the graph represents the weights of the members of certain high school math team. how many team members are included in the histogram. So the height of each rectangle box here or rectangle diagram here represents the frequencies for each math team. So the first frequency is 4, second one is 4. No, actually it's 5, 5, 4, and then 5 again, and then 3, and the last one is also 4. Okay. So basically you add in all these frequencies. So 5 plus 5, adding 4, adding another 5, and adding 3, and then adding 4 again. That turned out to be 26. So that means there should be 26 math team members. So just sum up all these frequencies, right? You can mark the top with frequencies. Let me just do this. Let me just I'll quickly show you this print screen, and then go to here. Okay, let me share with you. Here we go. So basically, you just mark the frequencies on top, right? On top of each. So this should be 5. That's 5. That's 4, and that's 5 again. That's 3, and the last one is 4. Okay. Now, once you mark all these frequencies on top of each rectangle box, you just add them. 5 plus 5, adding 4, adding 5, adding 3, adding 4. Right, that turned out to be 26. Okay. That's why the total frequency is 26. Okay. All right. Let's go back to next question. Okay, what kind of distribution has a bell shape, right? Bell shape should be normal distribution, right? The only distribution has a bell shape is normal distribution. Now, next question, 14. Okay, is a plot, what thing is a plot of pair data xy that's helpful in determining whether there's a relationship between two variables? We call this scatter plot. Scatter plot is a plot of order pairs, x, y values. X here is independent variable, y is dependent variable, and we try to figure out the relationship between those two variables. We're going to talk about that in chapter 10, right? When we talk about the regression analysis. Okay, this question 14 and question 15 are omitted. 16, okay, this is important question. Right, so this question, you are given a sample with how many data values here, turn out to be 10 data values here. And you want to find out the mean, median, mode, mid-range, okay, all of that. Given that dictionary has 1,453 pages, so you basically randomly select 10 pages and count how many words are used in each page. Then we get all this sample. So now I'm going to use Excel to do that. I'm going to open this in Excel. And let's run through the detailed calculation. Okay. Let me share the screen with you. There we go. So this is our data value here. Okay, if you want to label these the x value, right? Usually we call this x values. And basically, and we just first of all calculate the mean. So I'll do it here. So mean should be this, add up all these numbers. So if you get a total here, so sum up this, you can use the auto sum. Okay, you get 507, and then divide by 10, right? So the mean should be equal to you can also do this sum of all these numbers and dividing by count of all these numbers. You count how many numbers are there. It should be 10, and it should be 50.7, right? It should be the mean. Or you can just divide 507 by 10. You also get 50.7. And the median, you should sort these data values, right? In an increasing order. So sort smallest to largest. Expand the section. And the median, you can average the middle two. Okay, so middle two should be, okay, these two, right? These two are middle two. So basically you average those two numbers. So 52 plus 55 divided by 2. Okay, that's median. And in the mode, once you solid put into increasing order, you should be able to see the mode. No number repeats. That means no mode. Okay. You can double check using the formula, right? Mode. Just like that, and then it should give us a similar. Let's see, doesn't exist, right? This means not applicable. Median, you do the same thing. You can just get a median for the entire data set. It should be the same, right? That's just one way to double check whether you have the right answer. Okay. And mid-range, okay. Mid-range basically is the maximum data value adding minimum data value divided by 2. So 75 adding 32 and divide by 2. Okay, that's median. I mean mid-range. Mid-range turn out to be the same as the median. Okay, and then we get all these numbers. Let's see what else do they want. So 50.7 for the mean. Median is 53.5. Okay, select and the mode, no mode, right? And the mid-range. I guess we still have mid-range. So mid-range is 53.5 as well. And also the estimated number of words in the dictionary is, all right, so basically you just multiply the average, right? 50.7 by total pages. So on average, there are 50.7 words per page. You multiply by total pages, 1,453. And this turned out to be 73,667. 73,000. Run to nearest whole number, 667. So in this particular dictionary, there are 73,667 words. And is the estimate likely to be an accurate estimate of the number of words in the English dictionary? Yeah, so there should be no, it is accurate estimate of the total number of defined words in the dictionary, but it's likely that dictionary does not contain every word in the English language, right? So this is a very possible outcome here. All right. Any question on this? Okay. 17, I omitted. Question 18, I omitted. 19, okay. So here we go. We have a frequency distribution table, and you want to find the mean. And also you are given the actual mean, right here. They told us that the actual mean is 47.2 miles per hour. That's given here. And as you can see, you need to look up the formula sheet really quickly for some of the calculations. You can just click on our formula sheet, open that. And you can find all these formulas in chapter 3. Chapter 3 formulas down here, right here. So the mean for the frequency table, we're using this formula here. So you just need to create a column which is f times x. Right? All right. So let me export it to the Excel first. Okay, let's open it. So we also need to find out the midpoint. Share the screen with you. Here you go. All right, so insert it, format it a little bit, in the 2 more columns. Just midpoint and frequencies. Center that. Okay, so first one, you turn this as a frequency, right? Just turn it into a letter F, and then X is the midpoint. So we need to calculate the midpoint for each one of these. So first midpoint is 42 adding 45 and divide by 2. Okay, that turned out to be 43.5. And the second one is 46 adding 49 divided by 2. Okay, that turned out to be 47.5. If you look at the difference, must be 4, right? Because the class width is 4. 46 minus 42, that's 4. So it should be increase of 4 by 4. So if you want to do this number, adding 4, you can do that. And then you can follow the formula for the rest of them. And get all the midpoint. Now, in order to calculate the mean, we need a column F times X, meaning multiply the frequency by the midpoint. Okay, and you calculate one of them, then we can get the rest of them by just dragging that. Okay. Now from there, we're gonna sum up the total frequencies. Okay, get the total frequency, get a total of that. Okay, so get both of them. And from there, with the mean, we calculate the mean, X bar, right? So it should be sum of this, total of this product, F times X, divided by total frequencies, 52. That should give us the mean. And let's see how many decimal they want us to run to. Okay, 10th, meaning 1 decimal place. And so go back, let's run it to 1 decimal place. Okay, just trim down a little bit. So this turned out to be 47.1. And so the answer will be 47.1 here, you put it in. Okay. Now, which of the following best describe the relationship between the computed mean and actual mean? Actual mean is 47.2, computed mean is 47.1. So if you using the 47.2 minus, that will be minus 47.1, that will be 0.1 divided by either number 47.1. That should not be, it's less than 1%, right? It's definitely less than 5%. So the computing mean is actually close to actual mean because difference between the mean is less than 5%. Okay. They are very close actually. It's off by a little bit, maybe just due to some, rounding issues, off a little bit, but they are very close. So definitely it's less than 5%. You can also calculate that by find the difference between 47.2 and 47.1, which is 0.1 divided by 47.1. According to the calculation, will be less than 1%. It's 0.2% actually. That's the difference. So it's very, very tiny difference. Okay, any questions for this one?
Yes, can you go back to where you got the 47.1?
Definitely, let's go back a little bit. So first of all, look at the formula right now. I really want to show you formula one more time. So this is the formula we are using to calculate the mean. So we sum up the product of the frequency and the midpoint, total of that, and divide by total frequencies. So to go back to the Excel sheet. So we get this cell, which is F times frequency times midpoint, and get one of that. Then you get a total of this that would be the numerator. So that's why we're using E7 divided by C7. Total of the sum of the product, right? Sum of the product over sum of the frequencies, total frequency. Okay, and that turned out to be the mean. Okay.
Got it. Thank you.
Okay, very good. All right. So let's go back to the question 20 then. Okay, question 20. Okay, so this is a very good question. And some of you guys probably wonder, how the Regis office calculate your GPA, right? Actually, this is how they calculate your GPA. You can also do yourself, right? So basically, student earn grades B, F, B, A, B. Okay, this causes a corresponding credit hours. So this credit, two things important: the grade earned, and then the credit hours. Those are important. And then A represents 4 points, quality points. B represents 3 points. C represents 2 points. D 1 point. F 0 point. All right, so I'm gonna show you step by step here. So we call this weighting mean. Okay, so GPA is an application of the weighting mean. Okay, here, so we have 5 courses. So weighting mean, this is the weighting mean question. So the weight here is what we call the quality points. Credit is the weight, right? And the quality point is the, so the formula is summation of W times X, right? And divide by total weight. Okay. Weight represent the number of credits for each course. So we have 5 courses, and then the grade from each course, it's B, F, E, A, B. Okay. So based on each course grade, we have a quality point, and the quality point is here is X values. Okay. So the 4 is equivalent to 3 point, F is 0 point. Again, B is 3 point, and A is 4 point, and again, B is 3 point. Right. So very similar idea compared to this. So for any school, right, they use the same system to calculate the GPA. And then W here is the number of credits. Okay, so for the first course is 3 credit, second course 3 credit, third course 3 credit, 4 credit for the fourth course, and then 4 credit for the last course. Now, all we have to do is calculate W times X. The weight times the quality points, right? So X represents quality points. Yeah. So 3 times 3 is 9, 0 times 3 is 0, 3 times 3, 9 again, 4 times 4, 16, 3 times 4, 12. Okay, so all you have to do is sum up this column, sum up the total credit. So adding total credit, so summation of W here, 3 plus 3 plus 3, 9, adding 8, 17. Okay. So the denominator is 17. The numerator, you're just adding this summation of W times X. So 9 plus 0 plus 9, 18, adding 18 plus 12, it's 30, 30 plus 16, 46. Or you can just add it out, right? One by one. So this turned out to be 46. So numerator turned out to be 46. Now you just divide into that. 46 by 17. And this turned out to be 2.71, approximately. They want 2 decimal places, so approximately 2.71. So the answer here is 2.71. That's the GPA for this particular student in this semester. And 3.00, that's the dean's list, right? For this school, every school have different benchmark for the dean's list or cutoff point for dean's list. Some school using 3.5, some of the school using 3.3, so totally different. This school is they are using 3.00, so 2.71 obviously does not make the dean's list, right? So it doesn't make the dean's list. Any question on this? Definitely you can compute it in Excel. It's a lot quicker, right? If you input into Excel, but since this is fairly straightforward case, I show you how to do it by hand. And it's also doable in Excel. And this turned out to be 2.71. That's a GPA. And no, it doesn't, right? No, because the student has at least one, no, because the GPA is less than 3.0. Okay. That's question 20. Question 21. So it's talking about the standard deviation for the frequency distribution table. So now one more time, we're going to use this formula, right? Standard deviation for frequency table, which is this formula here. And we need to know f times x squared, f times x. So this is exactly similar examples from your Excel project number 3, right? So you have frequency distribution table, you want to get to the standard deviation. Now that's how we apply that. Okay, and first of all, let me export it into the Excel. So open Excel. Let's walk through the process one more time. Okay, and then let me share the screen with you. Okay, enable add-ins. So, okay, I'm gonna make slightly bigger. Okay, let me format it. So we need 3 more columns. Okay, center everything, and bold it, borders. Okay, so I'm gonna turn this as frequency f, right? And then we need to calculate the midpoint x. Okay, so the first midpoint will be average 25 and 31. So I'm adding those two numbers, divide by 2. Okay, get that. And the class width is 7, right? So the difference should be 7. Let's get a second one. Let's confirm that. 38 divided by 2 should give us 35. Yeah, because the difference is 7. So from there, you can just add a previous one by 7. Okay, get the rest of them. Okay, easily, right? And you can double check the last one, make sure it is 63. So adding 60 and 63, 66, and divide by 2. And that turned out to be 63. That means all the midpoints are good. Okay. Now we're gonna multiply frequency by the midpoint. Frequency times the midpoint. Get one of them, then just drag it, get the rest of them. And the last column is frequency times midpoint square. Okay, so you do frequency times midpoint square. Okay, and get a product that, get that, get one of them, and then just drag it to get the rest of them. Okay, so now from there we need total of 3 things. First one is the total frequencies. We need that. Okay, so sum up this, do auto sum, right? Sum up the product of frequency and the midpoint, get that. Sum up the frequency times midpoint square, get that. So once we have all 3 of them, then we're ready to calculate the standard deviation. So the standard deviation equal to square root open parentheses for numerator. So frequency, total frequency, sample size times total of frequency times midpoint square minus frequency times midpoint square that divided by the sample size times sample size minus 1. Yeah. So we have all of that. Close the denominator and then close the entire parentheses. Okay, then from there you can just enter, right, and then get the result. And this turned out to be 7.61. Let's see how many decimal they want on the question. They want 1 decimal, so just 7.6 basically. Yep. So you can just trim down to 1 decimal place, 7.6. Okay, any question on this? All right. 7.6 is the answer. Go. Question 21, we halfway through. Okay. Only 22. 23. Heights a man on baseball team and have a bell-shaped distribution, meaning it follows normal distribution with the mean 179 and then standard deviation of 6 centimeters. Empirical rules, right? So the empirical rule states that 68% of the data falling 1 standard deviation of the mean, 95% of the data falling 2 standard deviation of the mean, and then 99.7% of data values falling 3 standard deviation of the mean. So that if we know the mean and standard deviation, we'll be able to come up with those intervals, right? Contain 68% of the data, 95% of the data, and 99.7% of the data. So what is the approximate percentage of the mean between the following values? If you look at 161, okay, let me maybe show you the calculation here. Okay, here we go. So we have the first interval is 161 and then 197. Okay, so if you're using the mean here is and the standard deviation is 6 centimeters. Okay. So 161, if you look at it, the difference between 179 and 161, that's 18. That looks like 3 standard deviation of the mean. So if you do x bar minus 3 standard deviation, that's 179 minus 3 times 6. This is 179 minus 18. And this turned out to be 161. That matches with this number. Okay. This lower bound here. The upper bound will be x bar plus 3 standard deviation. It's 179 plus 3 times 6. That's 179 adding 18. This is 197. That matches the upper bound. So meaning this data value fall within the 3 standard deviation of the mean. So we know that that should be 99.7% of the data. 99.7% of the men are between 161 centimeters and 197 centimeters. Okay, that will take care of the first part. And the second part, 167. You can look at difference between 179 and 167, that's 12. 12 is twice as much of 6. That means that's 2 standard deviation on the left. Let's confirm that. So x bar minus 2 standard deviation should be 179 minus 2 times 6. It's 179 minus 12. That turned out to be 167. So it does match with the lower bound, lower limit, the upper limit x bar plus 2 standard deviation, 179 adding 2 times 6. 179 adding 12, that turned out to be 191. So we confirm that it's within 2 standard deviation of the mean. So this value should be 95%. 95% of the men are between 167 centimeter and 191 centimeter. Any question on this? Empirical rules.
How did you get the percentages for that? I'm not seeing,
Oh.
like, I don't get where you get the 95 and the 99.7.
Okay. So under the empirical rules, this should be from your PowerPoint. I think it should be on your PowerPoint. Probably not very, we probably didn't go over this too much, but the empirical rules states 68% of the data values fall within 1 standard deviation of the mean. Standard deviation of the mean. And then 95% of the data values fall within 2 standard deviation of the mean. Fall within 2 standard deviation of the mean. And so basically three given condition. And how does people come up with this? It's from ancient time. Nowadays, it's much more accurate. We can get to this percentage much more accurate. We will talk about it in chapter 6, right? You will see this in chapter 6 by the time we finish the normal distribution in terms of finding probability, and 99.7%. But back in, let's say, 2,000 years ago, there's no computer, no calculator, no technology. So this is what people come up with. That's why it's called empirical rule, right? Based on their experience working with the data values, data set, they come up with this. 99.7% of the data values falls within 3 standard deviation of the mean. And that's why this percentage, so basically compared to standard deviation and the mean, right? Those are important. Okay. And you should see this in the textbook also from your PowerPoint. Maybe there's not too much about this, but yeah, this is quite useful on a practical level. Yes. Does that make sense? Now you just have to remember this, but once we complete chapter 6, normal distribution, you don't have to remember this, right? You'll be able to find out what is the actual percentage. You'll be able to get much accurate answer compared to this empirical rules. But this is from the ancient time, when there's no technology involved. People just work with the data set. They come out with these empirical rules. It's pretty, precious back in the time. It still apply to now. It still works. Approximately this percentage are accurate. If you run it to whole percent, this is actually accurate answers. Okay. All right, and this is empirical rules. Now let's go to 24, which measure the variation is most sensitive to extreme values. The range, histogram, mean, median, right? Got to be range, right? Because range is maximum minus minimum, maximum value minus minimum value. Either one of that could be an outlier, right? Or like extreme values. So that's why range is most sensitive to these extreme values. And 25, for data sets having a distribution that's approximately bell-shaped, meaning normal distribution, then empirical rule, right, states that about 68% of all data values fall within one standard deviation from the mean. Okay, and then 95% fall in within two standard deviation of the mean, and come from the empirical rules. That's question 25. Question 26. I omitted 27. The data value is considered if its z-score is less than -2 or greater than 2. So the usual range. So usual values is between -2 and 2. So if it is less than -2 or greater than 2, then we call this unusual values, right? So the data value is considered unusual. We call these extreme values. And you can also call that they are potential outliers. Okay. So all these concepts are connected, and z-score becomes like an index, right? We use to identify those usual values from unusual values. So it's within the normal range or usual range, -2 and 2, then that's a usual value. Outside that, it's less than -2 or greater than 2, unusual values. Okay. All right, question 27, 28. It's about complement event. So event A denotes some event. So what does A bar with the line on top? We call this A bar denote. We call this complement event. It's a complement of event A. So if probability of event A is 0.998, what is the value of the complement of event A? It should be the complement will be 1 minus that. So the total probability for event A and a complement event A equal to 1. If event A has a probability of 0.998, so the complement will be the rest of them, so 0.002, right? What does A bar denote? Complement of event A, meaning that A bar and A share some, no. Complement, they don't share any, right? Consists of all outcomes in which event A does not occur. They do not intercept, meaning they do not share anything. It's either A or A bar, right? Either or. So if probability of A equal 0.998, then complement event, it's basically 1 minus that 0.998. This turned out to be 0.002. Okay. So you can just leave as a decimal answers. All right. Any questions on this? That's 28. That's is if PA probability of event A equal 0.998, is A bar unusual? Yes, it is. If it is less than 5%, it's unusual. This is just 0.2%. It's very highly unusual. Okay. Okay, so this question is about probability. To the right, the outcomes are possible when a couple have 3 children. So we know that there are A outcomes, right? And then the question actually give you all these possible outcomes here. So you don't have to construct a tree diagram to get all of this or analyze it to get all the outcomes. You could just look at all these outcomes and then come up with the answer for this. So among all 3 children, now exactly 0 boys. 0 boy meaning all girls. So girl, girl, girl. That's only one outcome out of total A outcomes. So 0 boy will be 1/8. Okay. Yeah, that should be the answer. What is probability getting exactly 3 girls out of 3 children? 3 girls, girl, girl, girl. Again, it's 1/8. 0 boy and then 0 boy, 3 girls, they are equivalent. If you're getting 0 boys, it's 3 girls. Okay, so they are the same event. And what's the probability of exactly 1 girl? So now again, you search through this list. So this one satisfies, right? Boy, boy, girl. And the second one is boy, girl, boy. Third one is girl, boy, boy. So I have 3 outcomes satisfy this condition, 1 girl out of 3 children. and that should be 3/8. And we spent a lot of time on this type of questions, so I hope you thoroughly understand this. Okay, do you have any question on this? All right, now let's move on to question 30. Yeah, okay, so the data in the following table summarizes blood groups and IH types for 100 typical people. So we know that the sample size is 100, meaning if you add up all these numbers within a table, it must be 100, right? You can confirm that. If one person is randomly selected, find a probability getting someone who is not group A. This is group A right here. Group A have 40 people, right? 40 in that categories. So everything other than group A, meaning you gotta add up group O, group B, and group AB. So not in group A will be, group A has 40 people, right? Total 100, meaning the remaining will be 60. So it's 60 over 100. Okay, and 3 decimal, they want decimal numbers, so it's 0.6. They want 3 decimal, 600. Okay. All right, so this that's pretty much it. Just figure out what is the event here. It's not in group A. Group A. That means everything other than group A. So add up all these numbers in group O, group B, and group AB. Okay, so sum up all those numbers, you get 60 divided by 100, 0.6. Even though they asked you to run to 3 decimal places, but if you just leave the answer as 0.6, it's good because it's very running answer. So you don't have to follow this exact random rules if you don't want to. Yeah. So the answer is 0.6. Okay. Then question 31, I omitted. Question 32. A or B indicates. So if you go back to Venn diagram, A or B basically indicates you are. So if you draw the Venn diagram, this is even A, this is even B, this is the intercept, right? In the middle is the intercept. So
You
even.
don't see your screen
Yeah,
besides
okay.
the Math Excel.
All right, okay. So how about here? Okay, this is good now. All right, so this is, so you draw, we call this Venn diagram. So in this Venn diagram, we have even A, even B. So A or B indicates it's same thing as saying A union B, meaning you're gonna want everything in A and everything in B. This symbol is called union symbol. So everything in A, everything in B, also their common section, right? So it means everything within A and B. So the probability that even A occur, yeah, they both occur, right? So there should be, answer should be C. C best describe this. Should be the probability that in a single trial, even A occurs, even B occurs, or they both occur, meaning they intercept. So C is the correct answer. Also, we have another notation called A intercept B, right? Or A and B probability is totally different. A and B. This indicates just probability A intercept B, meaning just this intercept section right here. So if you draw the Venn diagram, this is A, this is B. So this event basically is intercept section, meaning both event A and event B occurs. All right, so okay. The difference between and or, right, in terms of the language. So this is question 32, 33. Okay, the table below contains the result from experiments of polygraph instrument. So just basically testing whether people lied or do not lie, right? if 4 of the test subjects are randomly selected, you see 4 of them, without replacement, find the probability that each case, the polygraph indicates the subject lied is such an event unusual. So basically you're selecting 4 of them, right? Without replacement. So you pick a subject who lied, and then you put it back, right? Yeah. So let's look at it. Maybe let's open Excel. Take a look at this, these different categories. Neighbor editing. I think if you turn into Excel, the table look much better. Okay, it's organized much better. Okay. So now here we have this positive test result and negative test result. This is what called 2 by 2 continuous table. Because we have 2 rows and 2 columns. And here we just want to figure out how many of them lied, right? So this 37 of them lied out of total. So let's come up with the total. So sum of this, get 35, sum of that, get 37. If you get the sum of this, you get a total positive test result. Sum of this, you get a total negative test result. Guess I would just change this to total. And then the total people they surveyed should be 72 people, right? That should be the case.
When
Mhm.
does it, sorry, can you go, when does it include only one category, like only the people that didn't lie or that did lie, and when do you add up everyone?
Okay, one more time. I think, yeah, this is a very good question. You should try to understand the table setup. You see, if you look at just out of all the people they surveyed, the people who lied, you see, is under this column here, the second column here, 37. So no matter whether they have positive test result, meaning the polygraph test also indicates they lied, right? That confirms they lied, or they failed to confirm they lied, right? But just out of 72 people, 37 of them lied, right? So if you sum up this, that's the total people who lied. And the total people who did not lie will be this, right? 35. You sum up those. And now if you look at the first row is no matter whether they lied or they do not lie, the polygraph test confirmed they lied, right? So some of them, it's wrong result, but some of them are correct result, right? 31 are correct result, but that does not matter. So total of positive, 44 positive test result, 44 positive, right? And 28 negative test result. Okay, and then this 35 indicates total people who did not lie, right? And this one is total people who lied. That's all. So this actually separates, but they do have intercept, right? Because if you look at this 13, actually it's the intercept of positive test result and then did not lie, right? So each number here has a very unique element behind it. Okay, so here we know that 37 of them lied out of 72 people. So we're picking 4 subjects. You want to find out probability of all 4 subjects lied. Look at picking the first one. We're gonna get 37, right? People who lied out of 72. Okay. And the key thing here is the question tells us it's without replacement. So what this tells us is if you pick a subject who lied and you just throw it away, meaning it's no longer there. So what this tells us in terms of the probability is when you pick the second subject who lied, there's only 36 subjects remaining who lied, right? Out of only 71 subjects remains. Okay, without replacement. Okay, I should make sure. So this is a given condition without replacement. And then by the time you get to the third one, so you multiply by 35. Only 35 subjects who lied. Right? Only 70 people remains. Because you already picked 2 out of 72. So now, by the time you get to the last one, only 34 subjects who lied remaining, divided by 69. So you're just basically multiplying those 4 fractions one by one, and you should get the result. I guess I will use Excel to do the calculation here. So this result turned out to be paste. Right, so it's 0.064142. And see how many decimal they want. They won't run to 3 decimal place as needed. So we go back to your Excel sheet, run this to 3 decimal, so it's 0.0642. Okay, so this should be the answer. But any question on this? First of all, is understand the table. This is 2 by 2 contingency table, 2 by 2 table. Different tables could be 2 by 3, but this is very typical 2 by 2 contingency table. So I have 2 rows, 2 columns. They do have intercept. Each intercept have different meanings, right? And also row total and a column total means different things, totally different things. Just make sure you identify those carefully. That will help you, tackle the problems like that.
How did you know you had to stop at 34 divided by 69?
Because we know that only 4 subjects, and you see, all 4 subjects lied, meaning you only pick 4 people, right? Four subjects out of 72. And this is first one, second one, third one, and last one, fourth one, right? Then it's reduced by 1, reduced by 1, reduced by 1. Same thing for the total people. Once you pick 1, it's gone. That person is gone. Does that make sense?
Yes, thank you.
Mm-hmm. Okay, very good. And let's go back to, and this is question 33 and question 34. Maybe I'll read that one as well. So 2 events A or B are, if the occurrence of one does not affect the probability of the occurrence of the other, we call this independent, right? They do not affect each other. So the 2 events are independent. And if they are independent, then the multiplication rule applies. Okay, you can apply the multiplication rule to find the probability. And question 36, all right. Describe one notation probability of event B given that event A occurs. So this is what we call the conditional probability. Given that condition A occurs, right? So the probability of event B occurring, given that event A has already occurred. So C is the correct answer. And this is exactly the definition of the conditional probability. Right? So the given condition is event A occurred. And what happened to event B? Right. So this is question 36, 37. Okay. The data represent the membership of a group of politicians. If we randomly select one politician, so if you look at this table, let's see how many total politicians, we're going to look into that. What is the probability of getting a Democrat given that a male was selected. Okay. So this is very typical conditional probability. And first of all, let's calculate all of these different categories and look into the detailed information here. So the total amount of the people here, we are, open it first. So you add up all these different numbers, all these 6 numbers, that give us the total partitions they surveyed. And out of that, we have different categories. For some reason, it doesn't allow me to open. Give me 1 second. Let me open that one more time. Yeah, it is open. Okay, it's open now. All right, let me share the screen with you. It's right here. Okay. Okay, so this is partition examples. All right, so we have this is 3 by 2, right? We have 3 columns and then 2 rows. So it's 3 by 2 continuous table. And again, each category represent different things. Okay, so let's calculate the total, the row total and column total. So total on the column side, if you add up 8 and 35, that means we have 43 Republican partitions. So total 43. No matter whether they are female or male, okay, doesn't matter, right? Total is 43. If you add up the second category, A plus 61, that's 69 Democrat partitions, including male and females. Independent, adding 2 and 7, 2 and 5, you get 7. So if you sum up this total, you get a I should do this. I should sum up this, sum up those 3 numbers. Then we have 1,219 partitions they surveyed. And if you sum up the first row, A by A adding 2, that's total male partitions, right? 18. And the female partitions, adding this, you get 101. If you're adding those to 18 plus 101, you get 119. So meaning they have a total total partitions here. It's 119. Okay. And now the conditional probability is they want to find out is it, let's go back to the question. So they want to find out getting a Democrat, given that a male was selected. That means you're going to look into the given condition is a male, right? Or the male partitions. So the total of them is 18. And we want to find out Democrat, percentage of Democrat, given that it's male. Okay. Out of all the male partitions, you want to look at percentage of the Democrat. So that should be A over 18. Okay, so this is the easiest way to understand the conditional probability. It's looking to the given condition here, which is male, 18 males in total. And out of 18 males, only 8 of them belong to Democratic Party. So that will be A over 18. And that should give us the answer, A over 18. It's 0.4444. Okay, 0.444, right? It goes on forever. Okay. And the question wanted us to run it to 3 decimal place, so it'll be 0.444. 0.444. Okay. Do you have any question on this? So this is conditional probability. Question 38, it's about a combination. You could, evaluate a given expression, express the result using the usual format for writing numbers instead of scientific notations. So C represent combination. So you're picking 2 subjects out of total 46 subjects, and then order does not matter. Okay, so this is a typical combination, and you could get it done in Excel pretty quickly. In terms of combination, so you do COM. Yeah, I'll share the screen. Yes. Okay. This represents combination. So we're picking total number is 46. Pick 2 out of 46. Okay. Choose 2 out of 46, and then we get that 1035. That's the answer. So the answer is 1035 for that. And if you
In Excel, in Excel, can you do also the ones that order does matter?
Yeah, of course. Yeah, if it is permutation, meaning same condition, PERMUT means permutation. So 46 picking 2, right? That should be this 2070. Okay, because we rearrange those 2 people, you have 2 ways to rearrange it, so double that. Okay, I can also show you how to do it by hand, right? No problem. For that, for this, it's 4062. Let me show you really quickly how to do that by hand, just in case you want to do it by hand. So we got a 46C2. Okay, so NCR, right? So we have n factorial. So I just want to show you the general formula here. So it's n factorial over r factorial over n minus r factorial. Okay, so right here it should be 46 factorial dividing by 2 factorial times 46 minus 2 factorial. All right, and we get 46 factorial is 46 times 45 times 44 all the way to 1, right? 2 factorial is 2 times 1. And then this is 44 factorial. 44 factorial is 44 times 43 all the way multiplied to 1. Right? As you can see, everything after 44 will be canceled. So basically we just have 46 times 45. That's exactly 2070. And divide by 2. Okay, so it's 1035. Okay. For permutation, if it is permutation, if it is NPR, it will be n factorial over n minus r factorial. So as you can see, it is 46 P2. It should be 46 factorial by 46 minus 2 factorial, because we arrange those 2 members, right? You picked. So 46 factorial is 46 times 45 all the way to 1. And the other one is just 44. This is 44 factorial. So it's 44 multiplied all the way to 1. And everything after 44 get canceled. 46 times 45, that's 2070. And that's the difference between the combination and permutation. And again, just strictly apply the formula, and you can quickly look up the formula in the formula sheet, right? Definitely it's available, and yeah, NPR, NCR, right? Just use those formulas and then make sure you know what N and R is, and the rest of them just pretty straightforward. And that's question 38. Okay. Question 39, yeah. So this is 47, picking 2 out of 47. Yeah, let's quickly do that in Excel. So now using permutation, now instead of 46, it's 47, right? You're picking 2 numbers out of 47 total numbers, and order matters. Okay. Here we do rearrange those 2 numbers in a sequential order. So that turned out to be 2162, right? In terms of permutation, 2162. Okay, so this is question 39. Okay, and then question 40. Find the probability of winning a lottery with the following rule. Select the 5 winning numbers out of here from 1 to 36. The total are 36 numbers. And the way how you come up with the correct counting is by taking 36 minus 1, adding 1, right, including the first number. And that's why we know there are 36 numbers between 1 and 36. Okay. So meaning we picking 5 winning numbers out of 36, and then here the order does not matter, right? In any order, okay, meaning order does not matter. As soon as you have those 5 winning numbers, you win the lottery game. And so the probability of winning, we know that probability of winning is only 1 winning numbers, right? So it's 1 divided by, here we have combination, right? So we have 36. C, picking 5 numbers, C5. Okay, so it's a 1 winning numbers over whatever total winning number, whatever total numbers here is. We know that it's 36 C5. Then the quotient of that will be the probability. And again, we can easily get it here. So we do combination. We have total 36 numbers, picking 5 winning numbers, get total possible combinations, which is this. And remember, we only have 1 group of winning number divided by total group of numbers. And that turned out to be the probability. And let me turn into a decimal number. Yep, so that should be it. And then how many decimal they want? Let's look at it. Yeah, type of integer or simplified fraction. So they want a fraction, so it'll be 1 over 337,000. They don't want the decimal answers. 376,992. 376,992. It's 376,992. Okay. So that's how you do it. Okay. Do you have any question on this? So you can calculate the probability of winning for any games, right? For any Mega Million, as soon as you know how many numbers are there, how many winning numbers are drawn, then you're good. You'll be able to find out the probability for each one of those games. Okay, that's question 40, question 41. I'll make it 42. Okay, so as they pick 3 lottery game, so this is very good questions. Tell you how to calculate the expected value, meaning on average, what is your expected gain or loss, right? When you play any games, like if you go to casino, play any gambling games, you follow the same rules, right? As soon as you know the probability, and then the winning, the payout for winning, how much money you lose each time you play the game, then you'll be able to calculate the expected value. So in the stay pick 3 lottery game, you pay $1.26 to select a sequence of 3 digits from 0 to 9. First of all, you need to know sequence of 3 digits. What this tells us is there are 1,000 possible numbers there. So the way how we calculate that, is digit, 3 digits, right? First digit, second digit, third digit. For each digit, there are 10 numbers possible because between 0 and 9, 9 minus 0, adding 1, that is 10 numbers. So you know that the first digit has 10 numbers, second digit has 10 numbers, third digit has 10 numbers. So 10 by 10 by 10, that is 1,000 numbers. Okay, and that's one way to look at it. Also, if you look at a sequence of 3 digits, it will be starting from 000 all the way to 999. Okay, that's two extreme cases, the smallest combination, the largest combination. And you can also use the 999 minus 000, adding 1. That gives us 1,000 numbers. Same result. One of them using probability concept, the other one just counting, right? Basically counting how many numbers there, using the proper rules to get the total numbers. So we know that there's 1,000 numbers possible here. And how many different selections? 1,000, right? 1,000 different selections. And what is probability of winning? Remember, there's always one group of winning numbers. So here is 1 over 1,000. So probability of winning is 1 over 1,000. You want to turn it decimal, it will be 0.001. Okay. And if you win, what is your net profit? Remember, if you are winning, you're getting $351 net profit. Total payout is $351 and then 89 cents, right? And remember, you pay $1.26. It's like this is upfront cost. It's gone. Once you pay to play the game, that money is gone. So that's why the net profit should be excluding that. So $351.89 minus $1.26, and that turned out to be the net profit. And this turned out to be $350 and then 63 cents. Yes, and then we can also easily figure out what is net loss, right? Net loss will be negative, since its loss is $1.26. Okay. And from there, once we have all this clear, then we can construct a table. So the outcomes here, either you win. If you win, you get a net gain, right? Net profit. If you lose, then you have net loss. So only two conditions, or two outcomes here. If you lose, you have a net loss. And this $X represents monetary reward or loss. So here if you win, net profit is $350.63. If you lose, then the net loss is $1.26. And a corresponding probability, the winning probability is 1 over 1,000. We already calculated that earlier, right? So it's 0.001. That's a winning probability. And the probability losing is a complement. So there are 999 losing numbers. So 999 over 1,000, so it's 0.999. And multiply across, right? So the expected value will be X times P of X. And 350.63 times 0.01. And that turned out to be 0.350363. And then the other one is negative 1.26 times 0.999. And this turned out to be negative 1.25874. If you sum up those two, that's the expected value. So the expected value is the average of those outcomes, right? Those two outcomes, so it's negative 1.25874. 0.874, adding 0.35063. And the difference is the expected value. And typically we run the result to two decimal places. That make more sense. Run to cent. So the actual result is negative 0.90811. If you run it to two decimal, this is approximately 0.91. And the interpretation of this is, on average, every time you play the game, every time you play this pick 3 game, you expect to lose 91 cents. Expected lose 91 cents. That's the interpretation of this expected value. It's like average outcomes, right? So you can use it to guide your, activity or your willingness to play the game based on this outcome. Also, like investment activity, same thing. If you invest in the stock or the bond market, you want to see what is your expected return, right? Same way to calculate that, or average return. That's how you do it. And that's question 42 about the expected return. Question 43. Okay, so last question. What kind of variable has infinitely many values associated with measurement? We call this continuous random variable, right? Only continuous random variable has infinitely many values specified in a given interval associated with different measurements. Okay. That's pretty much it for the review session. And your actual midterm will look similar to the review questions. So I suggest you guys, if you still feel not so confident about certain problems, you should work on it one more time before you take in the actual midterm when you come back from the spring break. And do you have any other questions or any other general questions?
I know that there's a due date for this. Do you mind expanding it so we can
I did. I even sent you an email about that last week.
Okay.
I sent it till the end, I think after on April 5th. So all the quizzes you have until April 5th right now.
Oh, I was specifically talking about the midterm review. It says that it's
Midterm review. Oh yeah, definitely. I forget to extend that.
thank you.
Yeah, definitely. You got it. You'll be due on April 5th, right? Yeah.
Professor, is the midterm review graded?
Midterm is graded, yes.
So the midterm
review, it's optional, but it's highly recommended, right?
Yeah, but if we don't it does we don't need to get a good grade on it because it won't count towards our final.
You don't need to, right? You don't need to get a good grade on that, right?
Mm-hmm.
But it's helpful, definitely.
Professor,
Mm-hmm.
do you know the last day of classes?
Last day of a class, right? Sure. I can give you a tentative day. It should be a fairly accurate one.
I think it's the 12th of May.
I think so. Let me quickly double check the FIT's academic calendar so I can give you a short answer. Yeah.
Because I know we missed a class because of a holiday, and last semester we had to make it up after classes were done.
Yeah. No, we won't do that. Don't worry about that. I won't make you do that. So last day for all Tuesday class. Okay. Let me see. 12. Let me see.
It says May 17th for last all Monday classes.
Okay. So I guess it would be May 17th. But
The final is on the 12th, though.
The final. No, 12 is it's a Wednesday though. Oh yeah.
On your syllabus, it says that we have the final on the 12th.
Okay. Yeah. Yeah, you're right. So we could end the class on May 12th. Yeah. So, but you will be, in that case, you have to take the final Wednesday. So, yeah, so that, I guess that will be the tentative, tentative last day of the semester. So May 12th. But I will remind you, right, we take the final exam on Wednesday. So on that Monday, I guess, on the 9th, we will be able to do the review. No, 10th. 10th is the Monday. So do review on Monday, then you'll be able to take the final exam on Wednesday, May 12th. Okay. So now the tentative day will be May 12th. Okay. Unless something changes, right? Something happens, but I highly doubt it. So May 12th should be your final day of the semester. And after May 12th, the semester ends, so we do not meet anymore. Okay.
Thank you.
All right, very good. Any other questions? Okay. So
What is the midterm open, Professor?
midterm will be open on April 5th when you come back from the spring break.
Okay,
And open it, and you take it during the class, right?
okay. And it'll be on Excel?
Oh, yeah, you can use Excel and a formula sheet. That's
No,
allowed.
but it's Math Excel?
Math Excel. Oh, definitely. Midterm and final exams will be located in the Math Excel. You're right. I just didn't release it yet. I have midterm exam here. I just didn't release to you guys yet. You will take it on Monday, April 5th. Okay. All right. Any other questions? If not, enjoy your spring break. I see you guys. I talk to you guys when you come back from spring break. Okay.
Thank you, Professor.
No problem, guys. Okay.
Thank you.
No problem. Bye.
Thank
Professor, I
you.
have one more
Yeah,
question.
sure,
How much
totally.
time do we have for the midterm?
Same amount of time like our class. So class
Oh,
have
okay.
1 hour 50 minutes. So you have 110 minutes.
Okay,
Be
thank
more
you.
than sufficient. Don't worry about it.
Okay.
There's only 25 questions in your actual midterm. It's a lot less compared to the midterm review. Yeah.
Okay, awesome. Thank you.
Okay, great. No problem.
Okay.
Okay, bye.
Thank you.
No worry. Bye-bye.